In this video, I'd like to talk about how we can have a table that's vertical like this, but sometimes you'll see tables that are actually horizontal. So if the table is horizontal, what's going to happen is the independent or the x value is going to be not on the left-hand side because this is horizontal, but it's actually going to be on the top. So you're going to have x on top and y on the bottom. So the independent variable is always going to be on the top, and the dependent variable is going to be on the bottom if you have a horizontal table that looks like this. So I'm just going to rewrite everything here, but in this format. So we start off with 0, 0, like all direct proportions do. And then x is 1, y is 10, x is 2, y is 20, x is 3, y is 30. Okay, so these two tables mean the exact same thing. They're just written in different forms. But if you want to find the constant of proportionality, meaning you take those fractions and you set them equal to each other, you're going to do it in the exact same way. So remember, the constant of proportionality, which we're labeling with a k as a shorthand, is our y variable divided by our x variable. It's always that. So it's 10 divided by 1, 20 divided by 2. Do you see that if you're going to do 10 divided by 1 here, because y is on the bottom row, it is a little confusing, but just remember that the y still stays on top. So y is always over x when you make your constant of proportionality, even though if it's in a horizontal table, you have to switch it because unfortunately here, when we do tables like this, the x is going to be on the top. So you just need to know to switch it. So the y is always going to be on top and the x is on bottom when you have this equation. So just take it when you have this table, just know that you need to flip it. So it's 10 over 1, 20 over 2, 30 over 3, and it all reduces to 10 over 1. Okay, so I just wanted to point that out about some of these horizontal tables. The other thing I want to talk about is not only have we created tables and we've created graphs from those tables by plotting these points, remember all of these points are coordinates that you can actually plot on a graph in a straight line. The other thing that we're going to be doing is representing these relationships in an equation. So you can represent this relationship in an equation that I'm going to show you right here. So the equation that we're always going to be writing is y equals kx, okay? Where k is this constant of proportionality, and then the y and the x are actually just going to stay y and x. So when you actually are writing your answer for an equation, you actually want to have literally the letter y and literally the letter x in your actual final answer. The thing that is not going to be literally there is the k. The k is not going to be a k, but it's going to be whatever the quantity it is representing, which is the constant of proportionality. So remember here, if we were to take these tables and write an equation that described them, remember that our constant of proportionality was 10 over 1, or just 10. So then you can replace k with 10. So if I were to write this table in an equation form, I would say y equals 10x. Now y and x, we actually still leave there. Why? Because there's lots of x and y's. Look at all these x and y's. We don't want to limit ourselves to one particular x and y. We want a whole range of x and y's. So that's why when you're writing an equation, you do actually want to keep the x and you keep the y in your actual answer. So when you're typing in your answer into GoFormative or on the quiz, you actually do want a y and an x. The only thing that's a number is the k, and you'll figure out what the k is by putting y over x, and you'll find that constant of proportionality. So that's how you turn tables into equations. So sometimes the constant of proportionality is not a whole number like 10. The constant of proportionality could be a fraction, or it could be a decimal. So let me show you an example of a table where the constant of proportionality is maybe 2/3. Okay, so let's start off with a nice table here. We have our x and our y. We start off with 0, 0. And let's say we go to 2, and then, well, how about, let's say 3 and then 2. Okay, let's say 6 and then 4. Let's say, I don't know, maybe 12 and then 8. Okay, so if I were to write our constant of proportionality, I will write k. Instead of writing out constant of proportionality, just put k. K equals, remember, it's y divided by x. Let's see what we get. So this is 2 divided by 3. This is 4 divided by 6. This is 8 divided by 12. But do you see that 8/12 reduces to 4/6 and 4/6 reduces to 2/3? So our k is 2/3. K is the most reduced form that you can get. So if I were to write an equation that represents this table, it would be y equals kx. But we know what k is now, so we take away the k and insert the 2/3. So this is the equation that you would type into GoFormative. Y equals 2/3 x. Leave y, leave x. It's okay to leave those. It's the 2/3 that replace the k, and that's the important thing, okay? So this is an equation that is showing the exact same relationship. And we can also have other kinds of equations that maybe don't look like this, but we can get them into that form. So this is called the standard form. When you have y equals kx, we'll call that the standard form, the standard equation that we want. Y equals kx. We'll call this the standard form. Okay? Why is it standard? Because when you have y completely by itself over here, and then you have a coefficient of k right in front of x, then whatever the coefficient of x is, you know has to be the constant of proportionality. So if I'm asking what is the constant of proportionality, if you're given a standard equation, all you have to do is look what's right in front of the x. Super easy. What's not so easy is if you're not given a standard equation. So here's an example where you would need to manipulate an equation into standard form. So what does manipulate mean? Manipulate literally means to change with one's hands, to actually rearrange something. Okay, so it's kind of like we're rearranging something but on paper. So if we were given something that looked like this, 1/3 y equals x. This is not in the standard equation format, is it? No, because the standard equation format is y equals kx. Not anything in front of the y. We want y by itself, and then we want something nice right in front of the x, which is not happening here. So we need to algebraically manipulate or rearrange this equation so it actually is in y equals kx form, and so we can see what the true k is, because it is not clear to me what the k is here. Do not answer what the constant of proportionality is unless your equation is in standard format. So we need to get this into standard format. How do we do that? Well, you may have been thinking about already. Look at this. In order to get y by itself, completely isolated, what if I do this? I'm going to multiply this side by 3/1, the reciprocal of 1/3. Remember, back to our last unit, whatever you do to one side, you have to do to the other side, because it's an equation. So I need to multiply this side by 3/1. Do you see that 3/3, this cancels out to just 1. So this goes away, bye-bye. And I'm really left with 1y, or just y by itself. And now I have 3x over here. Now remember, x times 3 is the same thing as 3 times x, so I can algebraically manipulate it into y equals 3x. So see, we had an equation that didn't look like it was in standard form, because it wasn't, and we didn't know what the k was. But after doing our jujitsu algebraic skills to manipulate it into the standard form, it's very apparent as to what the true k is, and the k is 3. So you can say the constant of proportionality for this equation in reality was 3 all the time. So that's how you can algebraically manipulate equations. So I'll let you get to it, and I will see you when I get back. Thanks.